chapter of class 10th NCERT, which is chemical reaction and equation. Before moving into class 10 syllabus, you should be able to answer what is the valency of the element and the symbols. You should also know the atomic number, which is very useful for you when you read this class 10 chapters. Come, let's move into the video. So the chapter we are going to be looking at is chemical reaction and equation. When you enter this chapter, we should understand what is chemical reaction. What do you mean by chemical reaction? Whenever a change occurs and a new substance is formed, it is a chemical reaction. It is a statement. Let's understand it by example. See, first, you all know what is physical change. When water is freeze, it turns to ice, which you can again return to water by melting it. Whereas a chemical change, burning of magnesium ribbon, it is the first activity that is given in your book. Look at here. It is activity 1.1. I am using new syllabus book. You should also use new syllabus so that it will be easy for you. So what they are explaining in this activity is that you take a magnesium ribbon and when you burn it in presence of air, which is oxygen, you should always remember air denotes oxygen. In presence of air, so when you burn it, it provides a dazzling white flame and the magnesium oxide powder. When you look at here, you can see that when magnesium ribbon burns with dazzling white flame, what flame does it produce when burned? It is dazzling white flame and it changes into powder. The solid is changed into powder, which shows that there is a change in the state during the chemical reaction. The powder is magnesium oxide. It is formed due to the reaction between magnesium and oxygen present there. When you burn magnesium ribbon in presence of oxygen, it is the wording, so you should be able to write when you burn magnesium, which is Mg, in presence of oxygen, which is O2, you will get magnesium oxide, which is magnesium oxide powder. And during this reaction, what flame is produced? It produces dazzling white flame. These are the key points in which majority of the questions asked in this topic. What reaction produces dazzling white flame? Which means when magnesium reacts in presence of air, it produces magnesium oxide with a dazzling white flame. It is magnesium powder. Let's see how can we identify a chemical reaction is taking place. Whenever there is a change in the state, as I explained in magnesium activity, there is a chemical reaction. And when there is a change in the color, like when you react lead nitrate with potassium iodide, you get bright yellow color solution, which is the yellow precipitate. Yellow precipitate. So when lead nitrate reacts with potassium iodide, it produces a bright yellow color liquid, which is lead iodide. It is the yellow precipitate, and a byproduct, which is potassium nitrate. So in this reaction, you will be able to observe that there is a change in the color, which shows that there is a chemical reaction taking place. Now let's see evolution of gas. When zinc, which is a metal, reacts with sulfuric acid. So zinc reacts with sulfuric acid, which gives zinc sulfate, and hydrogen gas is liberated, which shows that there is the evolution of gas and changing in temperature. When zinc reacts with sulfuric acid, it produces too much of heat that the equipment which you are using turns hot. So there is a change in the temperature too. So let's understand what is meant by chemical equation. Chemical equation is nothing but shortened notion of actually occurring substance, which is statement. Let's understand it. For example, you are writing magnesium ribbon burns with dazzling white flame and changes into white powder. So when magnesium is reacting with oxygen, it produces white powder. When you write that, it takes longer time and it doesn't feel more convenient for the person to understand. That is why we use chemical equation, which is the shorter form of writing and reaction occurring. There are two types of equation, word equation and skeletal equation. Word equation, when you write magnesium with oxygen gives you, this arrow denotes that this reactants are changed and giving you a new product. You should remember that whatever elements that is written in the left hand side are reactants and whatever elements are written in the right hand side is products. So when magnesium reacts with oxygen, it gives magnesium oxide powder. Okay, so word equation is also easy, but you can also write into skeletal equation, which is even more convenient for the user to understand. Magnesium, instead of the word magnesium we write Mg, which is the symbol of magnesium, and oxygen, which is O2, gives magnesium oxide. It is easier for you to write and you can understand it clearly. We have studied about the law of conservation of mass in class 9. You should always understand and remember that whatever reaction is taking place and whatever equation you write must satisfy the law of conservation of mass, which you have studied in class 9. What does it say? It says that mass can neither be created nor destroyed during a chemical reaction. So we have one magnesium here and two oxygen here, whereas we have only one oxygen right here, which shows that the mass of oxygen is reduced. But what actually it should be, mass should not be destroyed during a chemical reaction. So we should balance this equation. How can we balance? One easy method to balance is that first you write whatever elements are present in that equation. We have magnesium and oxygen. Reactants, product. In reactant side, how many magnesium element do we have? Only one magnesium element. Only one magnesium. Oxygen, two oxygen. Whereas we have only one magnesium in the product side and only one oxygen in the product side. When we balance this reaction, we should add 2 before this product. You should remember that this 2 does not only belong to oxygen but also it belongs to magnesium. So there are 2 magnesium in this product side and 2 oxygen in the product side. But whereas in reaction side we have only one magnesium. How can we balance? We should add 2 right here, which shows that there are 2 magnesium. So here also it is changing into 2. Now you can observe that mass of reactants is equal to the mass of products. Let us understand by some more examples. We have seen an equation already which shows zinc reacting with sulfuric acid gives zinc sulfate and hydrogen gas. Now let's display whatever elements are present in this reaction. Sulfur, oxygen, acid, hydrogen. Number of zinc element present here is 1. Here is also 1. Hydrogen 2. Here it's 2. Sulfur 1. Sulfur 1. Oxygen is 4 and here also 4, which shows that this reaction is already balanced. So the number of elements in the reactant side is equal to product side, whereas you don't want to balance any reaction. When you look into this lead nitrate reaction, you will be able to find that one lead atom, nitrate we have twice, here we have only one, so we add 2 here. This 2 belongs to the overall molecule, you should always remember that. Now there is a change in the number of potassium atoms, so you will be adding 2 here. Now you can identify that the equation is completely balanced. Once you balance the equation, you should always do not forget to cross check it. Number of atom lead 1, nitrogen nitrate twice, potassium twice, twice, iodine twice and twice. I hope you all have understand the balancing concept. Now let's move into types of reaction. The first reaction we will be looking at is combination reaction. So what is combination reaction, or how do we identify it's a combination reaction? Combination reactions has more reactant and single product. Keyword to remember: combination reaction. The reactants may have two or more while the product is only one. For example, let's take burning of coal. Coal is nothing but carbon, right? So carbon, when reacts with oxygen, it turns to carbon dioxide. So carbon when burnt gives carbon dioxide. Another example is formation of water. So when hydrogen gas and oxygen gas combines, it gives you water H2O. What you can understand by these equations, you have two reactants whereas a single product. Here also two reactant and a single product. So you should always remember that combination reaction has two or more reactant and a single product. Okay. One of the most important examples for combination reaction is calcium oxide reacting with water giving calcium hydroxide. Calcium oxide is CaO. It is called quicklime. You may also get a question like quicklime reacting with water gives slaked lime. Is it exothermic or endothermic? I will explain it. So calcium oxide reacting with water gives calcium hydroxide solution. Calcium oxide is powder. So when it is reacting with water, it gives you calcium hydroxide. By giving calcium hydroxide, it also produces too much of heat. So when calcium oxide reacting with water, it provides calcium hydroxide as well as it exerts too much of heat, which shows that combination reactions are mostly exothermic. Let's understand what is exothermic. So you would have understand by the word exothermic. Exothermic means liberation of heat. The word exo denotes liberation of heat with the product. Liberation of heat. While endothermic shows that the reactants need heat to perform the reaction. Endothermic means reaction in presence of heat or reaction with heat. So the word endo and exo is quite different. Exo means liberation of heat. Like in example, calcium oxide reacts with water to give calcium hydroxide and heat. Endothermic shows that the reactants need heat to perform and give a product. In book it is given that calcium oxide and water combine to form single product. Note the word single product. Combination reaction will have only one product, calcium hydroxide. Such a reaction in which single product is formed from two or more reactant is known as combination reaction. Combination reactions are exothermic as it releases heat. Okay, now let's see what is decomposition reaction. Decomposition reaction is exactly opposite to combination reactions. For example, you have ferrous sulfate. Ferrous sulfate, when you heat ferrous sulfate, which means the reactant needs heat to perform its reaction. So ferrous sulfate when heated gives ferric oxide, sulfur dioxide and sulfur trioxide. Ferrous sulfate gives ferric oxide, sulfur dioxide and sulfur trioxide. Sulfate color of ferrous sulfate is pale green. When it is heated, it gives reddish brown ferric oxide and pungent odor is produced by sulfur dioxide and sulfur trioxide gas. Remember, when ferrous sulfate is heated, it gives ferric oxide, sulfur dioxide and sulfur trioxide gas which produce pungent odor. Let's see another example. When lead nitrate is heated, we get lead oxide, nitrogen dioxide and oxygen. There is only single reactant while the products are many. Whereas in combination reaction, you would have learned that two or more reactants produce single product. Here, single reactant produce two or more product. So the key point we need to understand is that single reactant two or more products. This decomposition reaction is endothermic. This decomposition reaction is mostly endothermic because heat is given to the reactant to do its reaction. In the same way, heat is given to the reactant to do the reaction. We have three types of decomposition reaction. What are they? Thermal decomposition, the word thermal itself says heat. Thermal means heat. So all these reactions that I wrote above denotes thermal decomposition reaction because heat is involved in the reaction. Another type of decomposition reaction is electrolytic decomposition, where you observe this diagram. This shows that in a beaker we pour water, we connect two glass rods in the test tube with a 6-volt battery. So when electricity is passed through the solution, this water is breaking down. Water, which is H2O, is breaking down into hydrogen and oxygen. Understood? When electricity is passed through water, it is breaking down into hydrogen and oxygen. When you look closer to this diagram, you can observe that level of hydrogen gas liberated is quite higher than the level of oxygen gas liberated. Why is it so? Because the ratio of hydrogen in molecule water is higher than oxygen. See, there are two hydrogen atoms whereas only one oxygen atom is present. So, it clearly indicates that number of hydrogen gas liberated will be more as compared to oxygen. It is one of the most important questions that is usually asked. Why the hydrogen gas liberated is higher than the oxygen gas? So, you will be able to answer the question now. The number of hydrogen molecule present in water is higher than the oxygen atoms. Thereby, hydrogen gas is more liberated as compared to oxygen. Now, let's see photolytic decomposition. Photo says that light is passed to the reactant to perform the reaction. Let's take silver chloride. This is a symbol of silver and this is chlorine. When sunlight is passed through silver chloride, it is split into silver and chlorine gas. When sunlight passes through silver chloride, it is split into silver and chlorine. We need to balance this equation, right? So 2 chlorine, 2 silver. Another example is silver bromide. So same way sunlight is passing through silver bromide, it splits into silver and bromine. Silver and bromine gas. In activity 1.8, it is explained that take 2 grams of silver chloride, place that in a china dish, and when sunlight is passed through silver chloride, you get silver and chlorine. Same way, when sunlight is passed through silver bromide, we get silver and bromine gas. You should always remember the most important key point. These two reactions are used in black and white photography. Most important one mark which is usually asked, what are the reactions that are used for black and white photography? Silver chloride and silver bromide reactions. Photolytic examples of photolytic decomposition reaction are used in black and white photography. Now let's see the next type of chemical reaction. When the elements are arranged in decreasing order of their reactivity level, it is reactivity series. Okay. So this is reactivity series where first you have potassium which states that it is highly reactive as compared to these elements: potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, gold. Gold is least reactive element. That is why it is mentioned below. I can understand that it's quite difficult for you to remember. Let's learn a trick. It is potassium. So, please, sodium. Stop. Calcium. Calling. Magnesium. Me. Aluminium. Zinc. Zebra. Iron. I. Lead. Like. Her. Hydrogen. Her. Copper. Calling. Mercury. Me. Silver. Sweet. Gold. Guy. Can you understand? Can you easily remember now? Please stop calling me a zebra. I like her calling me sweet guy. When you memorize this statement, you can answer this reactivity series very easily. Please potassium, stop sodium, calling calcium, me magnesium, aluminium, zebra zinc, I iron, like lead, her hydrogen, calling copper, me mercury, sweet silver, guy gold. Please stop calling me a zebra. I like her calling me sweet guy. I hope this will be useful for you during your exam time. Once again, I will teach reactivity series. So potassium is reactive than sodium. Sodium is highly reactive than calcium. Calcium is reactive than magnesium. Magnesium is more reactive than aluminium. Aluminium is more reactive than zinc, iron, lead, hydrogen, and it goes on. When you see increasing order, you can say gold is less reactive than silver. Silver is less reactive than mercury. Mercury is less reactive than copper, and it goes on. Now we can learn displacement reaction. By the word displacement, you will be able to understand that we are going to displace something. Let's take a reaction, iron reacting with copper sulfate solution. It turns into iron sulfate and copper is removed. So in displacement reaction, we can understand by this equation that iron took the place of copper in the product side. When you look into the reactivity series, we can see that iron is highly reactive than copper. So what iron can do? It can displace copper. So iron displaced copper into ferrous sulfate and copper is removed. Let's see another example. Zinc reacting with copper sulfate solution gives zinc sulfate and copper. Here also zinc is highly reactive than copper according to the reactivity series. Therefore, zinc displaces copper in the copper sulfate solution and it turns into zinc sulfate solution and copper is removed. Now it's testing time. Let's take copper reacting with zinc sulfate solution. Do you think copper can displace zinc? Not at all, because copper is less reactive than zinc. So this reaction will never take place. I hope you understood displacement reaction. Now let's move into double displacement reaction. Double displacement reaction. Double displacement reaction is quite interesting reaction. We have studied a reaction in the beginning of the session, that yellow precipitate reaction. Did you remember? Yes. Lead nitrate reacting with potassium iodide gives lead iodide and potassium nitrate. Don't forget to balance this equation. For most of the equation, I may not balance, but you should always remember whenever you write the equation must be balanced and state symbols must be written. So when lead nitrate reacts with potassium iodide, lead is replacing potassium and taking its place, whereas potassium is taking the place of lead. So both the molecules are shifting their place, right? So we have already studied this reaction, right? We also observed a yellow precipitate forming. Let's see another example. Sodium sulfate reacting with barium chloride gives barium sulfate and sodium chloride. Here barium sulfate is the precipitate formed. So when sodium chloride reacts with barium sulfate, sodium is taking the place of barium, whereas barium is taking the place of sodium. In this reaction also precipitate is formed. What does this state? Double displacement reaction will always produce a precipitate. In all double displacement reaction, precipitate is formed. I hope you understood this concept. Let's move into the next type of reaction, which is oxidation reaction. Important and quite complicated reactions are oxidation reaction and reduction reaction. But when you understand the concept, you can answer it very cleverly. Oxidation reaction, the word oxidation shows that adding of oxygen or removal of hydrogen. By the word oxidation, you should remember that oxidation reaction loves oxygen and hates hydrogen. Let's see the example. When copper reacts with oxygen, it gives copper oxide. Copper is single here, whereas oxygen is added to the copper in the product side. When heat is applied to copper in presence of oxygen, we get copper oxide. You can see that copper is single here, whereas it is attached to oxygen. Another reaction, copper oxide plus hydrogen gas in presence of heat gives copper plus H2O. We observe that oxygen is added to copper. This shows that there is addition of oxygen and it is an oxidation reaction. This copper, which is brown, as you all know, the color of copper changes into black when oxygen is added. So color of copper oxide is black. When this copper oxide is heated with hydrogen gas, we get copper and H2O. Here hydrogen is removed and it turns into water. This removal of hydrogen shows that there is oxidation reaction. But there is also a twist. The oxygen here is also removed. This shows that there is a reduction reaction also taken place. What is reduction reaction? Reduction reaction is vice versa of oxidation reaction. Adding of hydrogen, removal of oxygen. Simple. Oxygen is removed. So it is reduction reaction. When both these reactions occur in the same equation or same reaction, we call it as redox reaction. Let's see some more examples. When zinc oxide is reacting with carbon, it gives zinc and carbon oxide. So oxygen is removed, which shows that there is a reduction reaction. This oxygen is added to carbon, which shows there is an oxidation reaction. It is completely a redox reaction. Now we successfully came to the final page of this chapter. I swear all of you would have experienced this corrosion process in your homes. What is corrosion? When some iron particles in your home are kept in a moist surface or when exposed to air, the moisture in the air turns the iron object into brown color, which is called rust. It is also mentioned in the book. You must have observed that iron particles are shiny when new but gets coated with reddish brown powder when left for some time because it is exposed to the moisture in the air. This process is commonly known as rusting of iron. All these points are very important. Reddish brown color of iron when exposed to air, rusting of iron. Some other metals also get tarnished in this manner. Same way you would have noticed silver ornaments which you use are turning black as it reacts with sulfur in the air. Whereas copper will turn into green color. These metals are said to corrode and this process is called corrosion. Now let's look at rancidity. You would have observed this in oily food items. So when fat containing foods or oily foods are exposed to air, they get oxidized and this becomes rancid, which is not good for health. So most of our parents suggest us to keep all these items in an airtight container which slows down the oxidation process. Successfully we have completed this chapter. I hope you understand this concept. If you wanted it to be more clear, you can watch this video again and again so that it will be easy for you to understand. So friends, I hope you understood these concepts. You can watch my videos again and again to make it more clearer. You can also guide your friends by sharing these videos to them too. See you guys in the next video. Keep watching. Don't forget to like this video, share it to your friends and subscribe to my channel. Thank you.